Hello, my name is Roy, and I will be teaching a class on nuclear chemistry. This is my boss Brandon, who's going to be my student for today. So we are going to cover the topic of nuclear decay and how to balance nuclear reactions. So there are four main types of nuclear reactions. There is alpha decay, beta decay, positron emission, and electron capture. Alpha decay is when an atom spits out an alpha particle, which is essentially a helium nucleus. And an alpha particle, as we would write it out, would be helium, and it would have a charge of 2, an atomic mass of 4. So we're going to practice out an alpha emission. So as you can see on your Regents reference table, we have, for example, plutonium-239 degrades by alpha particle. So you would write out the symbol for plutonium, which is Pu. And plutonium-239 would have a mass of, so plutonium would have a mass of 239. And as it would decay, you would write an arrow indicating a reaction, and then it would be emitting an alpha particle.
So that means what exactly?
That would be the helium.
Okay, so it just emits helium?
So it emits a helium atom, which
Okay.
would have a mass
2?
of, no, 2
Oh,
is
okay.
the charge.
Oh, okay.
So it would have a mass of 4.
Which is on top.
Yes.
Because over here you wrote it at the bottom.
Oh, sorry, that's...
Okay, so that's supposed to be on top. Gotcha.
Yes. All right, and then it would be helium plus the element that plutonium degrades into.
Okay.
So if we look on the periodic table, what is 2 less than plutonium?
Uranium.
Uranium, right. So it would be uranium. So uranium has an atomic number of 92.
So up here.
Yes. And then it would have, how much less mass would it have than the plutonium if we ejected an alpha particle?
So it's this number minus, or, yeah, this minus this, right?
No, so 92 is the atomic number,
Okay.
and 239 is the atomic mass.
Okay.
We write the atomic numbers at the top and the mass at the bottom.
Okay, how do I know what this mass would be?
So what is the mass of the helium? It's 2 neutrons plus 2 protons. So that would give it a mass of,
4?
right.
Okay.
So,
So that means this number minus 4.
yes.
Okay, so it's 235.
Yep, so plutonium-239 degrades into uranium-235, and we would put, yep.
Okay.
All right, so that is alpha decay. So then we have beta decay. So I have this nice little reaction to show you, equation to show. So beta decay is when a neutron degrades into a proton plus an electron. And it's basically when an atom spits out an electron. So what will happen when what will happen to the atomic number, the number of protons in the atom?
It'll go up by 1?
Correct. But the atomic mass will
Stay the same.
correct. So we're going to go to the reference table and find a good, all right, carbon 14 is an example of beta decay. So C for carbon. And so carbon, we would write here, we would write the atomic mass.
Which is 14, or?
Correct. And then we would have, and then carbon right here would write the atomic number, which is the number of protons, which is 6.
Right here.
Yes. I think that's where I screwed up earlier. All right, so carbon 14 is ejecting an electron.
So arrow.
Correct.
Arrow, and then ejecting an electron. Okay, got it.
So what is happening to the atomic number?
It's going +1 and then -1, so ending up with the same number.
Okay, so the nucleus of the atom is going up 1 proton.
Right.
So the atomic number would become
7.
7, which would be nitrogen.
Okay. So nitrogen.
Nitrogen.
Okay.
And because electrons have effectively 0 mass, what would the mass number of that be?
0?
Of the nitrogen, if it's not changing from carbon to nitrogen.
Oh. It would remain 6, right? Because your mass number is 6? Or is your mass number 14?
14.
Okay, so
Because
it would
remember
remain
then,
14?
Yep. Because remember, the mass is the total number of neutrons plus protons.
Okay.
And then the other product of your reaction would be an electron. And what is another way to write out electron?
Apparently a small e.
Yes. And then we would have a -1 for the charge and a 0 for the mass. All right. Then the next type of emission is called positron emission. So positrons are effectively electrons but with a positive charge. So in a positron emission, a proton spits out an electron and a neutron remains.
Okay.
So the mass stays consistent from the proton to the neutron, but the charge changes from +1 to 0, and we have an electron and a neutron as the products. So if we look at example of a positron emission, so we would have neon 19. So neon,
Just capital
N,
N.
19, and then the atomic number is 10. So we have a total mass of 19, 10 of which are protons.
Okay.
So if we are going through positron emission, then we would create our arrow for the reaction. And then one of the products is going to be a positron. All right, so what is happening to the atomic mass? If
It's going +1.
the mass,
That's this number?
yep, so if we have 1 on this
Oh, it's
side
staying
and
the
a
same.
1 is 0, yes, so it's staying
Oh.
the same. And then what is happening to the atomic number if we are turning one of our protons into a neutron?
It's also staying the same?
Now remember that the atomic number is the number of protons in the atom.
Okay.
So if one of the protons is turning into a neutron,
So it's going -1?
right, we'll have 1 less proton, so we'll go from neon to one below it, fluorine.
Okay.
And so we would write fluorine, yep, that would be the atomic number, and then there would you put the atomic mass.
Which is still 19?
Yep, still 19, good. And then the last type of reaction we would have would be electron capture. So that's when you bombard an atom with an electron, and a proton and a neutron combine together to proton and electron combine together to form a neutron.
Okay.
So the atomic mass stays at 1, and then we have a positive and a negative charge canceling each other out. So if we go on and find a beta decay on the reference table, so for example, gold 198, so AU is the symbol for gold. Yep, good job. And then we can find the atomic number of gold is 79. And so we're bombarding the atom with an electron, so what would we also have on that side of the equation?
You would add an electron.
Correct.
So plus an electron?
Yes. All right. And then then we need to figure out what the reaction spits out. So
I'm sorry, this is an electron, not a positron, right?
correct.
So this is a minus.
Yep. So we would have our reaction, and so all right. So the proton and the electron are turning into a neutron. So what is happening to the atomic number if we're turning a proton and electron into a neutron?
-1?
Correct. Because we're having one less proton in the atom. So it would go from gold to platinum. And then the atomic mass, if we're only adding an electron, should
Go down 1.
should it?
Or I'm sorry, not the number. The mass should stay the same?
Yes.
Okay. So this stays at 79.
And that is the basics of the 4 main types of radioactive decay. Thank you, Brandon, for helping me. And yeah.